Okay, so when you're fitting a least squares regression line to a set of data, you need to use your CAS calculator. We do not expect you to do it by hand. So the first thing you need to do is what we've done with the 3 meter regression line on the CAS calculator. You put your data into your table as I've got on this page here. Okay, so you can see I've got my data in this page here. You then need to draw your graph, which I've already done and I've shown you in another video. Okay, don't forget, choose your axes by pressing tab, okay, and make sure you get them right. From there you need to do menu, 4 for analyze, 6 for regression, and 1 for linear mx plus b. That will then fit the least squares regression line and give you the equation. Okay, so that's how you draw it, and then you just need to write that down and then relate it back to your variables. Remember, every time you do a worded question, guys, you must relate what y and x mean on the calculator to the variables in the question. So just quickly run through that again. Menu 4, 6, 1. Okay, there is a way you can calculate the least squares by hand, but you will still need your CAS calculator. But this happens when they don't give you data. So when you don't get the data to put into your table, what do? What they will give you in this situation is the mean of x. Okay, they'll give you the mean of y. They will give you the standard deviation of x. They will give you the standard deviation of y. And they will give you r, which is Pearson's coefficient. And using all of that information, you can actually work out the least squares regression line using some of these formulas. Okay, so we know that the least squares regression line is always in y equals mx plus c. And using the information they give you, so that x bar, y bar, sx, sy and r, you can actually work out the equation for m, okay, which is r sy over sx. So you can actually work out the gradient, and then you can find c by doing the mean of y minus m times the mean of x. So you need to find the m first, and then you can find c, and that will give you the equation. So for example, there's an example in the book, but I will give you another one. Let's say that x bar equals 124, y bar equals 116. Okay, sx is, let's say it's 6. I wrote 7, so let's stick with 7. Sy, let's call that 6. Okay, and let's say r is 0.8. Okay, no idea whether this will work, but we can use our equations to see. So m equals 0.8 times by sy, which is 6, divided by 7. So my gradient, if I get my calculator and work that out, comes out at 0.6857. Okay, so from there I can work out c. So c equals y bar, which is 116, minus m, which is 0.6857, times by x bar, which is 124, and if I calculate that, we get c is 30.9714. So my final equation, my least squares regression line for that data, is y equals 0.6857x plus 30.9714. Okay, so you can work it out by hand if you are given this set of things using these two rules. Okay, so that will happen at least in the exercises you have to do, and quite possibly in an exam as well.